All right, ladies and gentlemen, we're going to talk about properties of matter. So we can break properties down into one of two categories. They can be physical properties or chemical properties. And the reason why this is important is because, like it says there at the bottom, that each substance actually has its own unique set of physical and chemical properties. So this allows us to be able to tell what's what. So if you have an unknown sample, we can look at, well, what are its properties? And that can tell me then what it is. So let's dive into that. Let's look. So we have physical properties first are things that we can observe without changing what we have. So we've talked about how a substance is something that always has a certain chemical combination of things. So water is always H2O, always 2 hydrogen, 1 oxygen. That will never change. In fact, if we change that, then it becomes something else. So when we're observing the properties of water, we can observe that without changing it into something else. So some examples of that might be like its density. I could figure out what things float in it and what things don't float in it, or even whether water floats on top of oil or something like that. That's its density. The color of water, odor, taste, hardness, melting point, boiling point, all of those things are things that I can observe without changing it into something else. Now the tricky ones with that are actually melting point and boiling point. Those are tricky because we think that if we melt something, we're changing it. And we're definitely changing its form, its state, but we're not changing it chemically. So I put ice into my water, and when all of that ice is melted, it doesn't change the taste of my drink, right? Because it's just water. At one point it was frozen water where the particles were fixed together and just vibrating back and forth. But now that it's liquid, those particles are free to move a little bit more. But it's still 2 hydrogen and 1 oxygen. Boiling point is the same way. When you take water and you boil it, it changes into a vapor, but it doesn't change it chemically. It's still 2 hydrogen, 1 oxygen, because we could take all of that water vapor and actually condense it down again and turn it back into water. And this is what happens when you take a really hot shower. All of the steam, the water vapor from your hot water will condense on the mirror and turn into little water droplets. So we didn't change water into anything else in that process. We just changed its form. And so if you look at these here, we've got density, color, odor, taste, hardness, melting point, boiling point. We could also even talk about length or its width. We could talk about its shape, its mass. All of those things would describe water in some way. Now, some of these properties, including the ones I just mentioned, some of them depend upon how much stuff is there. For example, if I've got a glass full of water, it takes up a certain volume, right? It fills it up a certain amount. Well, what happens to the volume if I dump out that water? Well, what happens is that my volume changes, that property changes. And so I went from maybe having a full glass of water to now it's only half full. Or is it half empty? I don't know. Anyway, I have got less water. Now, did that change the volume? It did. Did it change the mass of the water? If I took it to a scale and set there, it would weigh differently. Did it change the boiling point of water? It didn't. Water is still going to boil. Liquid water will still boil at 100 degrees, whether I have Celsius, whether I have half a glass or a full glass. It didn't change its melting point. It didn't change its hardness, right? So what I'm getting at is within physical properties, we actually can have another classification. And this is called extensive properties and intensive properties. And how I remember extensive and intensive is that I remember, the I in independent here makes me think of intensive. So intensive properties are independent of the amount of stuff there. So the fact that water, when we got rid of half of my glass of water, it didn't change the boiling point or melting point of water. It didn't change its taste. It didn't change its color. It didn't change its odor. Those things stayed the same. So intensive properties are independent or free from the amount of substance present. Whereas extensive properties, if you take water and you dump it out, it has less volume, it has less mass. Those would be extensive properties. Okay? So all of those contrast with chemical properties. And chemical properties are basically, does it react with other things? Does it explode? Does it burn? Does it rust? Those are ways to describe chemical properties. And to observe these properties, we change it into something else. So if we think about a wooden splint, I could go through and I could list all of the properties of a wooden splint, like the physical properties, and then I'd move into, well, what happens when I put a wooden splint into a flame? It burns. So that's a chemical property. And because when it burns, it actually is going to turn black and it's going to change color. And it's also going to be a little bit more flaky at the part where it was burned. So a chemical property is something I observe, and in the process of observing it, it changes into something else. That black part of the burnt stick is something else, chemically speaking. Okay? And the importance of all of this is that we, like I said before, is that we can identify unknown substances based upon their physical and chemical properties. Okay? So the most helpful ones are chemical properties, whether something burns or not, as well as intensive physical properties. So like density, that's something that can be used to say whether something's real gold or fool's gold. In fact, there's a story about Archimedes, I believe, who he was tasked with figuring out whether a crown was made of real gold or fool's gold, and he ended up figuring out that he could just put them in water. And that's the bell. But that would allow him to figure out whether or not it was legitimate gold or not based upon its density. Alright, so that's our sum of physical and chemical properties.